Basta.
Hallo, goedenavond, goedemiddag allemaal. Wij zijn voor de eerste keer bijeen met de talkshow Basta vanuit de OT 301 aan de Overtoom in Amsterdam. Basta is een initiatief van Amsterdam Alternative. Als alles goed gaat, gaan we dit elke week doen. En dit is dan de kick-off vandaag. En we hebben gelijk een enorm belangrijke gast. Namelijk George Monbiot uit Engeland. George Monbiot is een schrijver, activist en ook een journalist. Hij schrijft regelmatig stukken voor The Guardian. Maar hij is vooral beroemd als schrijver en als activist. Een van zijn laatste boeken is in het Engels verschenen als Regenesis. En binnenkort in Nederland te verkrijgen in Nederlandse vertaling als Een Nieuw Begin. Dat is eigenlijk het boek waar we het vandaag over gaan hebben. En omdat George Engels is, gaan we natuurlijk nu overschakelen op de Engelse taal. So George, welcome. This is the first issue of our new talk show, Basta. So everything is a little bit new, also for me. But never mind, we can have a nice chat, I think. You are here in Amsterdam for two things. Yesterday was the premiere of a film called Paved Paradise. Actually, it's a documentary. We can talk about that maybe a little bit later. But the other reason is that soon the Dutch edition of your book Regenesis will appear. And I wanted to talk about that first. So maybe it's a good idea. I don't know if you agree, but I thought maybe it's a good idea if we take it up chapter by chapter. Because there is a lot of subject matter in the book. So it would be a bit difficult to kind of summarize it in one single issue. So maybe if we go through it chapter by chapter, it will eventually become clear what the whole book is about. So let's start at the first chapter, because I think for me that was one of the most interesting chapters, because it deals with the soil. And maybe you can explain a little bit what the story of that particular chapter is and what is so important about the soil.
Well, the soil is arguably the most important of all our ecosystems, but we have disregarded it so badly that we don't even consider it to be an ecosystem. We just see it as stuff, as a bunch of minerals and organic matter which plants stand up in. But it turns out to be an ecosystem as complex and as abundant and diverse as a rainforest or a coral reef. And more than that, it's a biological structure. Like a coral reef, it's built by the creatures that live in it. If it weren't for the life forms living in the soil, there would be no soil. It's built, first of all, at the smallest level by bacteria, which make the little homes for themselves, little capsules in which they live, by using the carbon in the soil as glue, which they stick the soil particles together with. And those capsules have remarkable properties. If you air dry soil, it's still 98% humidity inside those capsules. And then you've got the tiny scuttling creatures in the soil, which are called microarthropods, and they turn those bacterial clusters into slightly bigger ones in which they live. And then you've got the giants of the soil, like ants and worms, and they turn those into the bigger structures in which they live. And it's fractally scaled, which means that it has the same structure at every level of magnification. And that is part of what gives it its structural strength. If soil was what we thought it was, just a mass of stuff, it would wash straight off the land. Any rainstorm, any windstorm would just sweep it straight off the land. But it's because it's been built by creatures in this fractally scaled pattern that it stays there. It also has extraordinary properties which we're only just beginning to understand. In 2020, a paper was published which said, we think we might know what soil is now. And subsequently, I've met the authors of that paper and they told me, in the light of further research, actually, we're not so sure. So it's fair to say we don't even know what it is. We don't at all understand this thin cushion between rock and air on which our entire lives depend. 99% of our calories come from it. But what we do know is that it behaves in ways which no other ecosystem behaves in. So to give you an example, if you reduce the carbon content of the soil, the entire microbial genome shrinks. All the DNA length across all microbes shrinks simultaneously in response to that carbon loss. If it rises, it lengthens simultaneously. But at the same time as it shrinks, the number of RNA operons rises, suggesting a collective metabolic response. So it's as if the whole soil is acting almost as if it were one organism. All the microbes in the soil are acting together in a synchronized way. We've no idea what that means, why it's happening. But there's another property of soil which I want to talk about because I think it's, well, for me, was perhaps the most fascinating and mind-blowing of all the things that I've learned so far about what's going on under the ground. And we've all got a lot to learn about soil. It's still a black box. But, and this is how plants interact with the bacteria and fungi in the soil.
George, could you move a little bit closer?
Sure. Because it turns out that plants can talk, and they talk in a very sophisticated chemical language. And it's a language which can be tailored. They talk in actually lots of different languages, and they can talk to particular microbes and no other microbes when they want to. And so when a tiny root hair, a baby root, pushes into a lump of soil, it'll send out a chemical signal that only one or two species of bacteria can hear. And there might be thousands of species of bacteria in that lump of soil, but only all the others can't hear it. And the bacteria exist in a sort of state of dormancy in the soil until they're woken up by this signal from the plant. And it's just these one or two species will wake up, and then the plant will flood them with sugar. And of all the sugars plants make from photosynthesis, between about 10% and 40% are poured into the soil to feed bacteria and fungi. And in response to these sugars, the bacteria multiply very quickly around the root hair to form one of the densest bacterial communities on Earth. And we call that zone around the root hair the rhizosphere. And the bacteria in that zone do three things that we know about for the plant in return for those sugars. One is that they deliver minerals to the plant because the plant can't really extract minerals from the ground by itself. It needs help from bacteria and fungi. Second, they form a defensive ring around the root, preventing pathogens, other bacteria or fungi or other disease agents from attacking that root. And thirdly, they help to fire up the plant's own immune system so that it can also fight off things which might be attacking it. Now, when you think about this very dense bacterial community, delivering minerals in exchange for sugars, defending the tissue of the root from attack, and firing up the plant's immune system, some people listening to this might have a little glimmer of recognition. They've heard this story before. There's something it reminds them of. It's like the human gut. In the human gut also you have these tremendously dense bacterial communities. They help to deliver nutrients from the food in return for taking sugars from that food. They form a defensive ring around our gut wall, defending it from attack by pathogens, and they help to fire up our immune system in just the same way as they fire up the plant's immune system. The rhizosphere, this zone around the root, is in effect the plant's external gut. It is the gut of the plant, but it's outside the plant. And this becomes an even stronger comparison when you consider that there are about 1,000 phyla or major groups of bacteria. And there are 4 which dominate in the rhizosphere. And there are 4 which dominate in the human gut. And they're the same 4.
Okay. Is there a reason why this completely interesting subject has been so neglected for such a long time?
Well, I would like to know. It is amazing the way we've neglected it. I mean, it's truly fascinating. I mean, partly it's very hard to study. It is very difficult to study because if you break open the soil, you've smashed it up, and so it's not the same thing that that you want to study. Once you've broken it open, all sorts of things start going wrong. So studying the soil while it's still there and still functioning is very difficult, and we don't yet have the tools for doing so. In fact, there's a team of us who are working. We think we found a very interesting new tool, but I'm not yet at liberty to talk about it. But there's at the moment, it's very expensive and very difficult to see a lot of the things that we would want to see in the soil. But I think partly it's that it's not considered glamorous. It's dirty. It's beneath us, literally and metaphorically. It's beneath our feet. And a rainforest is glamorous, a coral reef is glamorous, and they're beautiful. And you'd be hard put to call soil beautiful. But when you understand it, it's beautiful to the mind. It might not be beautiful to the eye. But it doesn't have that allure which the other ecosystems have, I think. And it's a terrible shame. We are primarily visual creatures, but because it's so hard to study and to understand visually, I think that could be one of the reasons why we've neglected it.
Okay. You already said it. Once you break open the soil, all kinds of things are going wrong. But that is what we do, for example, when we do agriculture. So basically, most of the rest of your book is about agriculture and the way that we have been farming and that we may be farming in the near or further future. So in the second chapter, you kind of zoom out a bit from the soil and start talking about agriculture and the different aspects of agriculture. Could you say something about that?
Well, so in that chapter, I'm looking at the global food system. Really, it's a chapter about systems and the great failing of our education. I don't know about in the Netherlands, but certainly in the UK and in the other English-speaking nations I know, is that hardly anyone studies complex systems. You can go all through school and all through university and never even know what a complex system is. And yet everything that's important to us in our lives is a complex system. The human brain is a complex system. The human body is a complex system. Human society is a complex system. The economy is a complex system. The financial system, the food system. Every ecosystem is a complex system. Every ocean is a complex system. The pattern of currents around the world, an ice shelf, all of these things, they're all complex systems and they're all governed by a set of rules that complex systems have in common. But they are completely different from simple systems. And when we're taught about any of these things, we're taught as if they were simple systems. We're taught with like a diagram with a sort of flow going round, like a plumbing chart or an electricity diagram. But they operate on totally different principles, which is why complex systems are always taking us by surprise. So a complex system comes about as a result of billions of random interactions, which bizarrely, and it's something we just have to kind of take on trust, the result of those billions of random interactions is to create patterns and self-organization. So through what starts off as randomness, complex systems, universally, it doesn't matter what they are, they self-organize. And they have extraordinary self-organizing properties. And one of those properties is that within a given range of stress, they damp down any shocks which attack that system. So you might get a financial shock to a financial system. If the system is healthy and resilient, it'll damp down, average out that shock, and make it disappear. But if a system is losing its resilience, and there are some technical ways we can show when a system is losing its resilience, what that means, why it's happening, and it's again the same across all these systems, and it's hit by a shock, instead of damping that shock down, it amplifies it, and the shock becomes bigger as it passes through the system. And what I've seen in the scientific literature, going back now about 10 years, is a long series of papers saying the food system is losing its resilience. It's beginning to look like the financial system in the approach to 2008. And what's truly terrifying is that though these papers are very well documented, very well evidenced, there's lots of data showing that we are heading towards a similar situation as the financial system was. There's been no recognition of that in public life at all. Nothing. I don't know a single politician anywhere who understands that that's happening. I don't know any media organization except the stuff I've been doing which has covered this issue at all. I mean, it's as if we knew the financial crisis was coming, but we decided not to talk about it. But this is much worse. If the financial system had gone down, it would have caused a great deal of suffering. It would have brought down a lot of other systems at the same time. But if the food system goes down, then that's suffering on a whole other scale. Basically, the rich would eat and nobody else would. And while the financial system, when it came right to the brink of collapse, could be bailed out by governments using future money, you can't bail out a failing food system with future food. So one of the properties of complex systems, and this is why they keep taking us by surprise, because we imagine they're behaving like simple systems. A simple system will respond to stress in a linear and gradual way. But a complex system absorbs stress, starts to flicker, starts to transmit more shocks, but is still there, and then suddenly just collapses. And that collapse can take place overnight. And once it's collapsed, it's almost impossible to reverse that collapse, because there's a property called hysteresis, which in this context means that the energy required to reverse a system collapse is greater than the energy required to cause it. So the tipping can be very small. Like with the financial system, it was the US subprime crisis. Really, by comparison to the size of the global financial system, not a big deal. It had had far worse crises in the past, but because it had lost its resilience, it only took a little tap to knock it down. And we never know which that tap is going to be. We never know what the small impact that's going to collapse a system is going to be once that system has lost its resilience. But had it gone down, had the financial system gone down, had it not been bailed out in time, then it would have been like that for many years, possibly for generations. The collapse would have been very, very hard to reverse. If the food system goes down, we're finished.
Yeah. Do you think that this collapse of the food system will be a worldwide phenomenon then? Because, the food system is not the same everywhere. I mean, it's different in southern countries than in countries in the northern hemisphere. So how can that be a global phenomenon?
It's almost as homogenous as the financial system now. So, for example, 4 corporations control 90% of the global grain trade. It's extraordinary. That's far more concentrated than even in the financial system. It's a really dangerous state of affairs. These big 4 companies which basically control everything. And countries are far more dependent now on that grain trade than they ever were before, because the world has polarized into super exporters and super importers. So with every major arable commodity now, like rice or maize or wheat or soy, there's only 4 or 5 nations which dominate almost all the world's exports for that particular commodity. And there's an increasingly long list of nations which are now totally dependent on importing from those 4 or 5 nations. A lot of that grain passes through a series of very narrow pinch points, geographical pinch points.
Like the Suez Canal.
The Suez Canal, the Panama Canal, the Straits of Malacca, the Straits of Hormuz, the Bab el-Mandab, the Turkish Straits. And it only takes a couple of those to go down at the same time, and the food chain snaps. So, for example, if you remember back to 2021, this huge ship, the Ever Given, got wedged across the Suez Canal. And luckily, they were able to free it in about 5 days. But if they hadn't been able to dig it out, they would have had to unload it, to float it off, and that would have taken weeks. In 2022, Russia invaded Ukraine, and that effectively shut the Turkish Straits. Right? If those two things had happened at the same time, then hundreds of millions of people would just have lost a major part of their food supply.
I see that Adnan just arrived, so please take a seat.
Hi, Adnan.
Hey. On my other side.
Hey there. Great.
We're gonna talk to Adnan later on, but you can join the discussion if you want, of course. I'll put your mic open, and please put your headphones on and sit straight in front of the mic.
Yeah.
Okay.
So Adnan, I'm very glad to see him. He's someone I greatly admire, and is putting into practice some of the things that we'll be talking about. So in a moment we'll be coming on to that, and we can hear from you about the amazing work you're doing.
Great.
Or as much as you're prepared to tell us.
Yeah, sure.
Yeah. Okay. But coming back to the strains that are confronting the global food system, some people say, well, I mean, okay, this is true, but this is a kind of a function or a result of the way that we organized it by having big transports from one side of the globe to the other. So if we localize food production, the whole idea will be gone out of the window and no problem at all.
Yeah, and there's a very big movement around the world saying we need to localize food production. And I'm in favor of local production where it's possible. You know, I think that it's generally a good principle to be producing stuff locally if you can, because that can sort of generate better contact between producers and consumers. It can generate more of a sort of community basis to the market. It can be easier to see where things come from. You can operate at a smaller scale if you're not trading around the world. So these are good principles. They've been massively exaggerated in terms of environmental impact. You know, we seem to think that we can solve the environmental problems of food production by localizing supply, but that's because we've greatly overemphasized the impact of travel, of transport, food miles, and greatly underappreciated the impacts of all the other things going on with food production. And if you say to people, so why isn't the food system localized? They'll come up with all sorts of reasons, some of which are correct, you know, that it's corporate power has a role to play in it, the structure of markets, intellectual property. I mean, there's all sorts of reasons. But the reason scarcely anyone ever talks about is by far and away the most important one, which is maths. And the maths is straightforward, that the majority of people live in places which don't have large enough hinterlands to supply the food that those people need. We tend to live in cities, and most cities are not in the places where the very large expanses of agricultural land are. And so even if we got all those other issues out of the way to try to localize our food supply, we couldn't do it because there's simply not enough food can be produced locally to supply markets. People would starve. There was a study in Nature Food saying what's the minimum average distance over which the world's people can be fed with grain? It's 2,200 kilometers. To be fed with major staple foods within 100 kilometers, less than a quarter of the world's population could be fed that way. We are very dependent on these big, distant, remotely habited places like the US Midwest, the Canadian prairies, the Brazilian interior, the Russian steppes, the Ukrainian Chernozem, which are the places where a huge proportion of our grain is grown. And you can argue against all the distortions of capitalism. You can argue against all the distortions of corporate power. And we should be arguing against them. It's absolutely right. But you can't argue with the maths. This is a basic mathematical relationship. How much land is able to produce how much food for how many people. And that is why we cannot have a generally local food supply.
So everything like urban gardening or vertical farming, all these concepts can be thrown out of the window then?
Well, I'm a great fan of urban gardening. I spent much of my life doing it, and it's very good for my mental health and quite good for my physical health as well. And I feel connected, and there's some great communities. For a long time, I had an allotment, which in England, everyone is theoretically entitled to a tiny patch of land to grow vegetables on, and there might be 100 or 200 of these little patches within the area. Within the zone which has been set aside for allotments. I think you might have a similar system here, and it's a wonderful community thing, and you grow enough vegetables to feed your family. That's great, but it's only going to be a tiny proportion of our food supply can be produced by that means. I mean, urban farming is limited by the fact that you're in a place where there's very intense competition for land, and that land is extremely expensive. Like can be 100 times more than land in the countryside. So you're never economically going to be able to produce any sensible amount of food in there. As for vertical farming, in other words, growing vegetables, and some people even talk about growing grain in towers with tiers of trays where the plants are grown hydroponically. Look, I mean, I don't want to diss it completely. There are some very successful vertical farms in some of the cities in Britain, where they've got lights and pumps and heaters, and they grow very intensively, and they make a lot of money. But every so often they get busted by the police, and the farmers get led away in handcuffs. So it works with skunk, right? It's very successful as a way of growing skunk, because skunk is worth an awful lot of money. So you can do it there. But if you're trying to grow vegetables, let alone grains, which are worth much less money, you are competing, you're going head to head with horizontal farming. And horizontal farming doesn't have to build all these load-bearing structures, which cost a lot of money. It gets its light free from the sun. It gets a lot of its heat free from the sun. It gets a lot of its water free from the rain. You're having to pay for all that in a vertical farm. Now, the only financial advice I'd give to anyone is don't take financial advice from me, right? But even I could see that this was a turkey. And in 2010, I wrote an article, when it was just beginning to take off as a big thing, vertical farming. So this just doesn't make any sense. This is completely crazy. You can never make money doing it this way. It's just not going to work. But, in line with my other advice, nobody took my financial advice, understandably enough. And so since then, I've seen any number of startups set off there. We're going to grow all this city's vegetables in this one tower, and off they go. And within a year, they go bust. And then a whole new series of startups will do exactly the same thing, and they'll go bust as well. And nobody learns from anybody else's failures. They've all got this sort of miraculous vision of how they're going to do it. And invariably, every time when one of these businesses go bust, they say, we were ahead of our time. No, you weren't. You were ahead of physics, economics, and geography.
And fundamentally, to add to that, basically, you need to look at energy efficiencies, right? So what you're doing is you're turning sunlight into electricity by means of solar panels, so your efficiency is 20% over there. So you've just lost a lot of energy, and then you're recreating that energy through LEDs, so it's huge energy loss. So what is a better way to do that is, for example, just greenhouses, like we have a lot of them in the Netherlands. So I think vertical farms are competing against greenhouses, which are much more cost efficient. So it's really hard to get the economics right of vertical farms, even if your electricity would be very, very cheap. Because the efficiencies are just not there.
Okay. Getting back to your book for a moment, there are several examples in there of people, mainly in Britain, that do several kind of, I call them experiments, with farming and especially with taking care of the soil. Because, of course, if you're going to be a farmer, you have to somehow take care of the soil. Could you elaborate a little bit on these examples?
Okay, so I'll talk about a couple of them. I'll go through them fairly quickly because I want to move on to the subject that Adnan and I take a shared interest in, which I think is the most interesting, fascinating, actually, of all parts of this discussion. So we need much better ways of growing our grain and growing our fruit and vegetables. And we can't do without grain and fruit and vegetables. Those are important parts of our diet. In fact, we ought to be eating more fruit and vegetables than we do. And the Netherlands actually has got some really good models for vegetable production. It is doing a lot of things right there. It's not the only way of doing it, but it's a highly efficient and very land-sparing way of producing vegetables. And this is a very important aspect, land.
Land sparing.
Land sparing. So, we as environmentalists, sometimes we talk about land, but we always, in almost all cases, are talking about urban land. We talk about urban sprawl and how urban sprawl should be avoided. And it should. Urban sprawl is a very bad thing. It's bad for cities, it's bad for the countryside. But the entire urban area of the planet is 1%. 1% of the planet's land is built on. So all our homes, all our businesses, all our infrastructure occupy 1% of the land. The farmed area of the planet is 38% of the land. And much of that is wasted. It's used for very low productivity farming. In fact, by far and away, the biggest amount, about 26% of the planet's surface, is used for grazing animals, largely cows and sheep, which produce a tiny quantity of our food. It's a really profligate way of using land. In fact, you use more or less twice as much land for grazing animals as all other human uses put together. It's quite extraordinary. It's a really, and this is all land which would otherwise be occupied by wild ecosystems, by forests, by savannas, by natural grasslands, all of which are much richer in both species and in carbon than the pasture systems with which we've replaced them. And so we should all the time be aware of how much land we're using. It should be up there in our minds with greenhouse gases, with pollution, with all the other things. Land use, land use, land use, land use. Every hectare of land we use has got an ecological opportunity cost and a carbon opportunity cost associated with it. But we're just not thinking in those terms. So it's good that Dutch farmers are producing a lot of vegetables on a small amount of land. That's what they should be doing. There are some downsides, in that a lot of the water running off the area with the greenhouses is so full of pesticides you could use it as a pesticide. It is getting better, it is improving, but there are some pretty shocking examples. There are other ways of doing it. I was particularly interested in, I followed closely a man called Ian Tolhurst in the UK, who's managed to develop a form of vegetable growing which requires no fertilizer and no manure, and yet consistently raises the fertility of the soil. And what he's done is to recognize something pretty fundamental, really, that what we call agricultural soils in Northern Europe are actually woodland soils. They're forest soils. They're soils which had trees on them. And they respond best when they think they've got trees on them. They like to be in woodland conditions. And what that means is a steady litter of carbon coming down from the sky in the form of leaves, in the form of twigs, sometimes branches. You just got not a huge amount, but a steady and small amount. And so, among other very interesting things, he started to mimic that and to add 1 millimeter of wood chip on average on his fields every year. And that's had radical impacts. He's done away completely with the need for fertilizers or the need for manure, and is still raising his yields and raising soil fertility. And what that seems to have done is to help mediate the relationship we were talking about before between plants and bacteria and fungi. And to ensure that when nutrients are needed, they're released by the bacteria and fungi, a process we call mineralization. And when they're not, they're locked up, which is what we call immobilization. And the immobilization is as important as the mineralization, because if you're not locking up your nutrients when you don't need them, they flood out of the soil and end up in the river instead, which is where we don't want them. And so his techniques are very interesting. Some people have been able to replicate them, and some people haven't. And we don't know why. It's something to do with the soil, but because we know so little about the soil, we can't work out why. So the other thing I want to briefly mention before we get on to the issue which brings Adnan and me together is grain crops. You know, we just need much better ways of growing grain. And the fundamental problem really is that almost all our grain crops all around the world, with one or two tiny exceptions, are grown from annual plants which live and die within 1 year. Now, large areas covered by annual plants are pretty rare in nature, and they only occur in the wake of an environmental disaster. So a volcanic eruption or a landslide or a major fire, which kills off all the long-living plants, the perennial plants, and that creates an opening for the annual plants. They can then swarm into that gap, and they reproduce very quickly. They put a lot of their energy into seed, and so they can occupy that ground for a couple of years, and then the perennial plants come back in and gradually shade them out. So in order to grow our annual crops, we have to create an ecological disaster every year. We had to clear the land, and we do it by ploughing or we do it by spraying. And we kill everything so that it won't compete with these small, fragile annual plants, which can never compete against perennial plants. And we sow the seeds, and then we spray anything else which might compete with them, kill off all the other plants. If any insects come along, we kill them with pesticides. We give them lots of fertilizer, and we feed them as much. We might water them as well, and we pet them and primp them until they get big enough, and then they set seed, and we harvest it, and then we start the whole process again. So unsurprisingly, we're gradually destroying the basis of our subsistence, especially the soil. And at the same time, we're using huge amounts of fertilizer, of pesticide, of water, way beyond sustainable limits, and trashing whole ecosystems in doing so. So what if, instead, we could grow our grain on perennial plants? Plants which, they don't last forever in the soil, but can last for several years at a time, put down much deeper roots, so can provide a lot more of their fertilizer, a lot more of their water for themselves, tend to be much tougher and to have better immune systems than annual plants, and so can fend off pests, and are more environmentally resilient. Well, this has been a dream of scientists for about 100 years, and it's finally coming to fruition. Led by the Land Institute in Kansas, which is working in connection with various other research institutes around the world. They've so far fully commercialized one variety, which is a perennial rice. It's a short grain rice. It turned out to be a really simple process. No one could have guessed it would be as easy as it was. Basically, they just crossed short grain rice with a wild perennial relative. And hey presto, they got perennial short grain rice. It could have gone quite the other way. They might have had a perennial plant which didn't produce anything. But amazingly, after a few generations, they have yields which are as high as those of annual rice. And it's now being grown across many thousands of hectares in southern China. The farmers are desperate for the seed because you can greatly cut your costs by growing it. You need far less ploughing, far less pesticide, fertilizer, herbicide, all the rest of it, and much less labor. And they've got real labor shortage there. But also it causes a lot less soil erosion because you're not ploughing all the time. And soil erosion is a real problem in southern China. So and then there's a whole series of other crops now which are in development, some of which are coming pretty close. I see that of all the very interesting and promising things being done in arable farming, I think that's the most exciting.
Okay. Now, the food we consume is, of course, that consists of different kinds of nutrients, and one of them is proteins.
Mm-hmm.
Most of the people in the rich West get their proteins mainly from meat, not only, but mainly from meat. One of the ideas, of course, is that people should start eating less meat or no meat at all. You are a vegan yourself, if I'm correctly informed.
Yep.
But you also say in the book it's not realistic to expect that this movement of veganism will take off so quickly and so largely that whole swath of the population will suddenly stop eating meat. So we need to take our proteins from somewhere else. And this brings us, I think, to the other guest at the table. But maybe first, still, you could say something about what you came across in researching the book in Finland.
So, well, first of all, there's very good reasons why we should stop eating animal products. In fact, stopping farming animals is as important as leaving fossil fuels in the ground. Livestock farming hits just about every Earth system, and it's devastating in its impacts. It's by far and away the biggest driver of land use. It's a major cause of water use, of soil erosion, of so many other massive impacts, as well as creating more greenhouse gases and all global transport. We just can't afford to keep eating animals. There's just not the ecological space to allow us to do that. But as people become richer, their diets incorporate more and more animal products. So the global average is about 50% of the consumption of animal products that the Netherlands has, but people are converging towards the Netherlands level as they get richer. There's a principle called Bennett's Law, which is that as people become wealthier, they want more nutrient-dense diets, and that principally means animal products. And there's just not the space for that. I mean, already we have a situation where only 4% of the weight of mammals on Earth is wild, right? 36% of the weight of mammals is human beings, and 60% is livestock, it's farm animals. And only 4% of all mammals are wild. And that's just getting worse and worse because the human population is growing, but not very fast. It's now below 1%. You know, it's really a very low rate of growth, and it's heading towards a plateau pretty soon. But the livestock population is growing at 2.4% a year. So by 2050, there'll be roughly another 100 million tons of human being on Earth and 400 million tons of livestock on Earth. So the proportion of wild mammals will be even smaller than before. It's livestock that are eating the planet to destruction. That's a real population crisis. It's a livestock crisis. And that is what we need to stop. And as you suggest, I don't think we're going to do it just by persuading people to stop eating animals. It's just not a powerful enough mechanism. You know, human urge to eat meat is a strong one. And it's like trying to persuade people to stop drinking alcohol, through a temperance movement. It's only going to persuade some people. It's not going to be very successful. And so we need ways of producing something which is effectively identical to meat and to milk. Dairy is really devastating in a whole lot of ways, as I'm sure quite a few people in the Netherlands are now aware. Some people in the Netherlands are trying very hard not to be aware of it and to deny it, but it's also very, very damaging for a whole lot of reasons, particularly pollution. And we have to find new products which can be as close to animal products as possible, ideally cheaper than them, ideally healthier than them, which will appeal to people who are not like me. I don't miss milk and meat, but an awful lot of people would if you told them they couldn't have them anymore. And so the only way it's really going to work, I think, is going to be by producing better, healthier, cheaper substitutes. And at the moment, you can't really do that with plants. Plant proteins are very different from animal proteins, quite a different protein profile. The concentrations are pretty low, and they're tangled up with secondary metabolites, with strong tasting defensive products which the plants have. And so it strikes me that, for 12,000 years, we've been breeding and selecting multicellular creatures, plants and animals. And we've taken that about as far as you can possibly take it. In fact, I'd say that in some cases, we're taking it further than you can possibly take it. If you look at chickens, they literally can't support their own weight anymore because they've been so overbred to extract the last bit of efficiency from multicellular organisms. But we've scarcely begun to explore the potential of single-celled organisms. And that potential is enormous, and Adnan is one of the people realizing it.
Yeah. So basically, as I see, we've domesticated plants, we've domesticated animals, and now we're indeed at this moment where we're domesticating microbes. And we haven't fully tapped into the potential yet. So there are basically so many different kind of organisms, and only a small amount is used for food currently. Like obviously we eat bacteria, yeast every day, right? And when we're drinking milk, when we're drinking yogurt, plant-based yogurt. But there's a huge opportunity there that we haven't tapped into. And that's what we're doing right now. Yeah.
So could you say something about that? I mean, what exactly is it that you do or
Yeah,
that you
yeah,
develop?
sure. Maybe a bit of a brief intro. So what set me out on this quest, basically? So a while back, I wanted to have impact on our climate crisis and was really trying to understand what we're doing to reduce our emissions, what we have. I came to the conclusion that we have mainly everything to reduce our emissions from a technical point of view. It's mainly a political and social problem. But the thing that we haven't solved yet, there are a couple of big problems, and one of them is negative emissions, and the other is the way we do agriculture. So negative emissions, even if we stop emitting CO2 right now, there's a lot of CO2 that we need to draw down and get into our biosphere, for example. And the other thing is that our agricultural system is basically, beside fossil fuels, the other big problem is our agricultural system. It's leading, just as George said, to basically all of the other problems, like our extinction crisis, like pandemics, like pesticides, etc. So I think we've now reached the point where we see that the boundaries of our current agricultural system are failing. It's expired basically, and we need a new way, a new way forward. And so, what I think is interesting about food is food has defined mankind throughout history, right? From hunter-gatherers to, for example, the Industrial Revolution, right? So once the potato was introduced in Europe, starting the Columbian Exchange, basically we suddenly had a much more efficient crop that was able to reduce the amount of people spent to get more nutrients. So what the potato in hindsight did is basically make sure that more people could go out and work besides working on agriculture. And that has led to the Industrial Revolution. And then another big innovation was the Green Revolution. Basically, we got the Haber-Bosch process, we got artificial fertilizer, and that again basically sped up the amount of food we could create and increase the yields by making sure we add artificial fertilizer so that the plants will grow faster. That obviously created a lot of big different issues. But if you currently look at the world population, half of it is supported by the Haber-Bosch process. So if we don't have artificial fertilizer right now, we couldn't support like half of the population. And so now that we've reached another boundary, we need to think of what the next solution is. And so basically, it was actually George that inspired me with an article in 2019, because I was looking for these negative emissions and the way to reduce agricultural emissions. And then I saw this company, Solar Foods, right? By the article,
This is the company that is in the book.
Yes.
The company in Finland.
Yeah,
Yes.
exactly. So what they do is they use CO2 and hydrogen as a feedstock for fermentation.
You need to come a little bit closer to that.
Yeah, so they use CO2 and hydrogen as a feedstock for fermentation. And so my background is actually in physics. And as a physicist, I look at energy efficiencies, right? And so what's super interesting is that the energy efficiencies of such a process are very high, because basically nature is very good at creating complex organic molecules, but it's really bad at harvesting energy. So photosynthesis is really lousy. It has an efficiency below 1%. And we as humans, we're very good at harvesting energy through renewables, but we're very bad at creating these complex organic molecules. And we've been trying to fix photosynthesis for a very long time. That's not going anywhere. So the idea of combining these two systems into a hybrid where you have the best of both worlds is super intriguing, at least to me as a physicist. And so that's basically what Solar Foods was doing. So they use CO2 and hydrogen. Those are harvested through renewable energy, for example. And then basically try and find the most efficient way to create biomass out of it. And we can do that through fermentation, right? Instead of brewing beer, we brew microbes that we select for their food properties. And instead of using sugar, we use a feedstock that is derived from renewable energy. And so what we specifically at Farmless have looked at is the feedstock side. So basically you want the most energy efficient conversion from renewables to nature, to biomass, but you also want robust supply chains, and you want easy bioreactors. So Solar Foods uses CO2 and hydrogen as a feedstock. That's a little bit more complex because they're gases. So because they're gases, basically your organisms, they're growing, they have the CO2 as a carbon source, they have the hydrogen as an energy source, and their energy limitation is basically the amount of hydrogen, how fast it can arrive to these organisms, right? So you must imagine that you're growing these things in like large fermenters, like just like we're brewing beer, right? Large steel vat, and we're supplying these nutrients, but then your hydrogen is not going in quickly enough. So it means you need custom bioreactors. So in that case, you need a special gas fermentation. So your capital costs increase. So it's a bit more complicated, basically. So what we've done is and obviously from an energy security point of view, if you have a local energy crisis, if your feedstocks are gases, it's also more complex, right? Because in case your energy price increases, now you need to source hydrogen locally. So that's also obviously a disadvantage. So what we looked at, all these different feedstocks and see which is the most efficient one, and basically from a supply chain point of view, which is the most robust one. So basically you want a supply chain that is liquid, has an existing supply chain that can be made sustainably. And so we found that's basically like simple alcohols, methanol in our case. And we use that as a feedstock to grow bacteria that we select for their food and functional properties. And so, for example, we might select for high protein content and a very good amino acid profile. So, for example, the strain that we're looking at right now has a better amino acid profile compared to eggs. And then we might look for specific functional properties, so that it might work well as a meat successor or dairy successor. And so basically that's what we're doing, right? And the reason to tie that in, why we're doing it is I wanted to find a way to store a lot of negative emissions and reduce the harmful effects of agriculture. And the amazing thing is that if you grow on electricity, basically as a feedstock, because it's so much more efficient compared to photosynthesis, and we don't need any arable land, right? So we can grow in a desert. It means we can give back all the land we borrowed from nature and rewild back our planet. So our process compared to, for example, beef costs 500 times less land, and that's non-agricultural land. And compared to plants, 10 to 100 times less land. And so now you come to the solution where with a tiny amount of land, we can produce a lot of protein and then rewild back our planet, reforest our planet, get the cheapest negative emissions possible with the most benefits, and then at the same time stop the harmful effects of agriculture.
Okay. I hear a lot of terms like efficiency, bioreactor. There were a couple of other ones that immediately scare people off, I think. You know, like, I don't know if you probably are familiar with the film Soylent Green. It's an old one.
Yeah.
But somehow...
No one's ever made that comparison before, have they?
I think basically the way to view it is, it's just like we're already doing it. So it's just like brewing beer, right? It's very similar to brewing beer. The only thing we change is we use different organisms and we use a different feedstock. That's it. So it's very much comparable to a lot of the products we're already eating. Like, for example, with any other fermented product that is produced on a large scale, like yogurt, for example. It's very similar to those processes. So for example, in our case, I'm definitely not against genetic modifications, but we don't do any genetic modifications. It's not needed in our case. So it's just basically what we're doing is we're domesticating these microbes. We're really looking at the tiny scale and selecting these microorganisms for our current day problems with the agricultural system. So we select them on efficiency, on nutrition, on functional properties, what we can do with it. So I view it as just as a continuation of what we've already been doing, and simply fermentation. But up until now, with fermentation, we've just like accidentally made these discoveries, right? That's how all these fermentations started. We left something overnight, and then it suddenly smelled good or bad. And once it smelled good, we're like, okay, maybe this is nice. Let's take something, let's replicate it, etc. And we've just come to an age where we have much more understanding of these processes, and now we're deliberately using those processes. So I think it's something that is very in line with what we've already been doing, but just with a new ID, basically. Instead of using sugars or agricultural feedstock, we use feedstocks that are made from renewable electricity.
Okay. And then, of course, there is the question of, well, I call it ownership, but maybe that's too limited, because it's basically it's a kind of systems change, because lots of people will probably become how is that called in English? Redolent. That they don't have any work anymore, and other people will have to start working in these bio factories or whatever you want to call them. But I mean, who owns these bio factories?
Yeah,
And
you can call them breweries. I think they're
or
very
breweries
similar
or whatever.
breweries.
So
Yeah.
how do you see that?
Yeah, sure. I mean, we've always had techno-economical shifts that led to different means of production that had left to jobs being changed from one to another. That should be done equitable, obviously. So we should push governments forward to doing that. But I think the writing is on the wall that this industry is going to change. But we should make sure that these people that's done in an equitable way. Regarding the equity, yeah, obviously that is an issue. We're a venture-backed company because otherwise this is not possible. So yeah, that's a place for governments to make sure that that is done in an equitable way. That's for me very difficult as a founder while you're venture-backed to do that. And obviously, we try to have so ethics are very important for us. So every choice we make, we try to think on a planetary scale what the outcomes would be. So we're really thinking on a large scale. So for example, we want to push forward that the land that we free up would be rewild, right? That's extremely difficult for us to guarantee, but that's something we want to push forward. But yeah, these are obviously all questions that governments with better regulations could help us with.
Okay. Yeah, you brought up the concept of rewilding, and that is also something that is in this book, but also in another book that you wrote before. Can you explain a little bit what is meant by that concept?
So rewilding is the mass restoration of ecosystems, bringing back ecosystems that we've destroyed, or at least allowing ecosystems to reform in places where they've been destroyed. They might not be exactly the same as they were, but they will be much more functional, much richer in species, much richer in connections between species, and generally much richer in carbon. As nature recovers, it draws down carbon dioxide from the atmosphere that we've already released. And we now know we've left it too late merely to decarbonize our economies. We need to do that as urgently as possible, but that won't stop us from breaching 1.5 or probably 2 degrees of heating. We also need to draw down as much CO2 from the atmosphere as we can, and the quickest, cheapest, most benign way of doing that is ecological restoration. But that's only part of our task, because we're also facing a 6th great extinction. Now, people think of extinctions as being, we'll lose some species. Well, yeah, we're certainly losing a lot of species, but actually what's happened with previous great extinctions is not just a matter of losing species, it's a matter of Earth systems collapse. Now, earlier on, we were talking about complex systems and the way in which those systems will suddenly collapse, go from one equilibrium state to an entirely different one. And that's happened 5 times in Earth history before. Well, the history of multicellular life before, it's happened 5 times, where there's been a total systems collapse. The one which is most similar to the one that we face is what happened 251 million years ago. Most of your listeners won't remember it. It was the Permo-Triassic extinction that brought the Permian period to an end. And it wiped out about 90% of species and nearly all large and medium-sized vertebrates, so nearly all the fish, nearly all the reptiles. And it pretty well brought Earth systems to a standstill. Everything just ground to a halt. The surface of the planet turned to desert, the soil all washed off, the ocean circulation system stopped. And it was caused we believe, by volcanic eruptions in what's now Siberia. And the first wave of volcanism produced toxic gases and acid rain. The second wave was more important, and that produced, above all, heating. And the reason for that was that the first wave of volcanism had made a rock cap over the volcanoes, and the lava couldn't escape out of the top. So the molten rock was forced through the sedimentary rocks instead, and they were full of coal and other hydrocarbons. So this was a crisis caused by fossil fuel burning, not by people, but by magma, by molten rock, burnt through vast reserves of fossil fuel which were there in Siberia. And that led eventually, after thousands of years, to between 8 and 10 degrees of global heating. But the main pulse of the mass extinction happened between 3 and 5 degrees of global heating. So that's within the kind of range we're talking about, but it took much longer then. We're doing all this in a few decades, whereas that was across millennia. And we face the possibility, I'm not saying it's a certainty, because we just don't know with complex systems. We never know exactly where we are in relation to tipping points. But the possibility of cascading collapse across the complex systems which comprise the Earth system, across ecosystems, across soil, across hydrological systems, water systems, across ocean currents, across atmospheric currents. And when one goes down, it can bring down the next and bring down the next. They're all very closely interrelated. And so the mass restoration of ecosystems isn't just to draw down carbon from the atmosphere. It's not just to have more wildlife and a nicer, more attractive planet. This could be absolutely essential to our survival and the survival of the rest of life on Earth. It could be the only thing that gets us through the century.
Okay. Maybe if you allow me to sum up the basic ideas in your book, in your latest book, it comes down to something like this, like we really have to reform the food system and the way that we do agriculture, especially raising livestock and stuff like that. We need to look to other kinds of ways to create or to generate proteins. And we need to rewild as big a portion of the planet as is possible to kind of prevent this catastrophe from happening. Is that correct?
Yep, that's a good summary.
Okay, so maybe now we can just spend a few minutes still on the film that you are also part of, Paved Paradise, that went into premiere yesterday in Tuschinski for a huge gathering of people. Now, one of the things that struck me in this film is that somehow, and that is also a little bit a question to you maybe, all of this talk about different ways of producing food, in a way, is what I call a technological solution to a problem that is maybe not technological in character. So there are people that are, for example, criticizing your ideas. I recently read a piece on the website Unheard by a British farmer that said basically that this urban guy George Monbiot doesn't know anything about agriculture. What is he talking about? But I mean, I don't want to go into the basics of his arguments, but what he's saying is that you don't know what you're talking about, and this is all technological solutionism. What is your answer to that?
Sure. Well, we don't need just technological solutions, because you're right to say the food system, it's a social system, it's an economic system, it's a cultural system, it's a political system as well. But we can't make these changes without technological solutions. It's a bit like saying people should use less fossil fuel. Yeah, and people should cut down their consumption, which is true. Of course we should. We should all cut down our consumption. But we don't have any substitutes for it. You just got to use less fossil fuel. It's as if we didn't have renewables, we didn't have wind power, we didn't have nuclear, but just told people to cut down fossil fuels. How successful do you think that would be? Yeah, without these technological substitutes, we can't do any of the other things we want to do. It's not a sufficient solution to the problems we face, but it is a necessary solution to the problems we face. It's not enough by itself, But in combination with the other changes we need to see, it can be enough.
So and to add to that, that farmer would probably use feed that is grown in the Amazon with a lot of fertilizer that is chemically produced. That's a technological solution, right? So don't forget, half of our population is already fed by technology. So we're already past the point that food is not technology. Food is technology per definition. Agriculture is technology, right? So we can't go another way at this point. We're already past the point of not using technology because we're already feeding half the global population with Haber-Bosch.
Well, a flint axe is technology. A spade is technology. It's just a question of which technologies we're going to use. Incidentally, that farmer, if it's the one I'm thinking of, he knows so little about this subject, he hadn't even bothered to read the book.
Okay. Well, I thank you. Yeah?
Yeah, I think one more interesting addition is regarding the rewilding and why the way we want to produce food is so essential is that up until now, all the biomass that you see, all life around us is basically due to photosynthesis. So every living being is due to photosynthesis, and basically the total amount of light that we can convert into plants dictates the total amount of life that we can sustain on our planet. And obviously we are having difficulties in sustaining enough life on our planet. So first of all, if you have this trophic pyramid. I don't know if you remember it from back in the days, but basically you have like your primary consumers, which are plants, primary producers, plants, primary consumers, like cattle, and then you go up higher. And then with every step in the pyramid, you lose to inefficiencies. And the first inefficiency is plants that are converting photosynthesis into stuff. But basically it dictates the total amount of life that we can have. If you eat lower down that food chain, it means that there's more life available up in the food chain. So that's literally why eating more plants would mean that there's more life available in the other trophic cascades. But what we're doing is we're not using that trophic cascade because we're using, for example, renewables. So for example, solar panels as the primary input of our food. So we're creating a complete new trophic cascade. So what that means is all of the food that we create during this process, it subtracts from our current pyramid, so it creates new ecosystems over there, and at the same time, it can sustain more people. So what our technology can do is increase the total amount of life that we can sustain on our planet, which means, given the fact that our global population is not increasing that much more, we can sustain more wildlife and more plants, etc., and more biodiversity around us. And that's a technical and fundamental difference of what we're doing right now.
Yeah. Okay. Well, once again, thank you very much for this conversation. And hope to see you back sometime soon in the Netherlands. People can buy the book soon. In Dutch, it's called A New Beginning, A New Begin. Well, thank you.
Thanks very much, Menno. Thanks. Adnan.
Thanks.
That was great.
Dit was Basta, de eerste keer. We gaan volgende week, denk ik, verder met de volgende aflevering. Dank jullie wel allemaal voor het kijken en luisteren.
Basta.